Mathers. Today we are going to work on topic 7-2, which is factoring out the greatest common factor. So factoring, we have to deal with factors, and factors are two numbers that we multiply together to get a product. So definition, in a multiplication expression, the quantities being multiplied are called the factors. So if I had 6, the factors of 6 are 1 times 6, or 2 times 3. So those are the factors. Just like in my expression, 5 parentheses x minus 1, the factors are 5 and x minus 1. Those are my factors. Those are the two terms that I multiply together, 5 and x minus 1. So those are the factors. The greatest common factor, or GCF, is the greatest number that is a factor of all the numbers. And so there are a couple different ways that you can find GCF. So we want to find the GCF for each of the following. I will show you two different ways, and you can decide which way that you like to go find the GCF. For 28 and 42, I like to find GCF by using prime factorization. And so when you find prime factorization, you would have to go in and list the prime numbers, break it down into the prime numbers. So for 28 and 42, basically the factors of 28 are 4 and 7. So I want to list the prime factors that make up 4, and that's going to be 2 times 2. And the prime factors of 7 are just 7. So I haven't changed anything because 2 times 2 times 7 is going to give me 28. Now I'm going to come up with two factors of 42, and that would give me 6 times 7. And then I want to come up with the prime factors of 6. And so the prime factors of 6 are going to be 2 times 3, and the prime factors of 7 are going to be 7. And so the greatest common factor, or the biggest number that goes in all of those, are the two numbers that they have in common. And so they both have a 2, and they both have a 7. So the GCF is going to be 2 times 7, which is 14. So that is one way. Another way that you could do that is you can make a T-chart with 28 and 42. I'm sorry, that's 42. And you can go ahead and you can list the factors of 28. So you can have 1 in 28. You can have 2 times 21, 3 times 14, 6 times 7, and then once I repeat, which is 7 times 6, that means that I listed all the factors. The factors of 42 are going to be 1 times 42, 2 times 21, 3 times 14, 6 times 7, and 7 times 6. And so you want to look over here to see the biggest number that they both have in common. And as you can see, the biggest number that they both have in common is 14. You can also get this from when I was showing you the other day. You can go to your graph and you can put 28 divided by x. You could go to graph and put 42 divided by x if you wanted to get your factors. I prefer to do prime factorization because I think it's a whole lot faster. Letter B, I want to find the greatest common factor. I want to find the biggest number that both these numbers have in common. And so I'm going to use prime factorizations for 18 and 75. So I'm looking for two numbers that multiply together that get 18. So I'm going to just start with 2 times 9, and then I'll break it down further. So I know 2 is already prime. 9, I can break that down into 3 times 3. So that's 3 times 3. 75, two numbers that come immediately to my mind are going to be 3 times 25. I know 3 is already prime, and then I can break 25 down to two numbers that are prime that are going to be 5 and 5. And then I want to look to see what do both of these numbers have in common. And so there's a 3 on the top and there's a 3 on the bottom. And that is the only number that they have in common. So the greatest common factor between 18 and 75 is 3. On letter C, there's 3 numbers. So that means that all 3 numbers have to have a number in common. So I have 12, 24, and 42. I already did 42, so I'm not going to go and redo that. So I know that's going to be 2 times 3 times 7. And 12, two numbers that I multiply together. I mean, it doesn't matter. I'm just going to start with 2 and 6. So I already know that 2 is prime. And then 6 can be multiplied 2 times 3. 24, there's a couple different combinations. You can start with 2 times 12. You can start with 4 and 6 and break it down. I know 2 is already prime. 12, we can break that down into 2 times 6. And then how can I break that further? So that's going to be 2. 6 can be broken down into 2 times 3. And then always go back and make sure that 2 times 2 is 4, 4 times 2, and then is 8, 8 times 3 is 24. So I haven't changed any of the values. I'm just listing prime numbers. So then I go look to see what do they have in common. They have a 2. There's a 2 here and a 2 here, but there's not a 2 down here. I see a 3, and a 3. So they all have to have a 3. So my greatest common factor is this 2 right here and this 3. So my greatest common factor is 6. Now you could go list, if you wanted to, you could list factors of 12, list factors of 24, and you can list factors of 42 if you really want to go do that. If you want to. I don't want to do that because that's going to take too long. All right. So let's see if we can find a pattern for x to the 5th and x to the 3rd. So we have x to the 5th up here, and we have x to the 3rd. So this x to the 5th basically means that we have 5 x's. This x to the 3rd means that we have 3 x's. So if we follow that pattern, that means that they have to share. So both the x to the 3rd and the x to the 5th both have an x in common. So I know they have an x in common. The top and the bottom also have another x in common. And once again, the top and the bottom also have another x in common. So the greatest common factor is, on this one, is if the bases are the same, we're going to keep the base and we're going to add the exponent. So it's x to the 3rd. So with variables, the greatest common factor, if the base is going to be the variable with the lowest or the smallest exponent. So with variables, our GCF will equal, if the bases are the same, it will be the one with the lowest exponent. Okay. So over here, we have 16m squared and 20m to the 3rd. So we're going to have to find the greatest common factor between 16 and 20. And then we'll break it up, and we have to find the greatest common factor between m squared and m cubed. So I'll find prime factorization for 16 and for 20. And so I'll just go and start with 4 and 4. So I'll break 4 down into prime numbers, and that's going to be 2 times 2. I'll break the other 4 into other prime numbers, and that's 2 times 2. Then I'll just pick 2 factors to start with, 4 and 5. 4 I can break into prime numbers of 2 and 2, and then 5 is already prime. And so then I find what they have in common. There's a 2 on the top and the bottom, another 2 on the bottom. So for this GCF, it's 2 times 2, and so that GCF is going to be 4. For my variable, I have an m and I have an m. We have an m, an m, and an m. And as you can see, if the bases are the same, it is the variable with the lowest exponent, which is going to be m squared. So it's this. So you ask yourself, which is smaller, a 2 or a 3? And that is going to be a 2, and that is why that is going to be a 2. So my GCF is going to be 4m squared. All right, so you take a second and see if you can apply what we just talked about for letter F. All right, so on this one right here, you're going to find the GCF between 22 and 66. We're going to break it down in between x squared and x cubed. And then when I look at it, there's a y, and then I don't have a y over here. And so remember that to find the GCF, they have to have the variables in common. Well, since there is not a y, then I will not have a GCF of a y. So they do not share. They do not share a y. I'll move that up so you can see that they do not share a y, so there's no y. So greatest common factor, factors of 22 are going to be 2 times 11. And then we can break this down into 11 times 6. And so this becomes 2 times 3 times 11. And so we can see that 2 and 11 are shared. So this GCF is equal to 22. We already talked about x times x, x, and x. We know it's going to be the smallest exponent, so that's going to be x squared. So our GCF is going to be 22x squared, and there is no y. All right, take a second and see if you come up with for letter G. All right, letter G is 10ab squared. So to factor means to write as a product. A product means multiply. That is the end game of multiplication, is a product. We can write each expression as a product of two factors. So 4x minus 8 equals 4 times the quantity x minus 2. This number outside of the parentheses is the GCF. So you ask yourself, what does 4x minus 8 have in common? What is the GCF between 4x and 8? The greatest common factor between 4x and 8 is 4. So if I was to divide each one of these by 4, what am I left with? And so the factors of that are going to be 4 and x minus 2. These are the factors of that. So when you take 4x and you divide it by 4, you are going to get an x. And when you take a negative 8 and divide it by 4, you get a negative 2, and that's where that comes from. All right, so the steps to factoring out the greatest common factor. Step 1 is we're going to find the GCF. Step 2, we're going to divide each term by the GCF. Step 3, we're going to write the answer as a product of the GCF and your answer from step 2. Remember, the number outside of the parentheses is the GCF. 10x plus 30. Step 1, we're going to find the GCF between 10 and 30. So hopefully you're able to go ahead and be able to tell me that that GCF is 10, but if you can't, then you should be able to see that this is 3 times 10, and so this is going to be 3 times 2 times 5, which is right here. And so I can see that my GCF is 10. For my variables, I have an x, and then I don't have one, so that's why the GCF is going to be 10. So we're going to divide by 10. So we already found the GCF. We divided each term. The 10 is going to go on the outside. This is my GCF. We're going to write it as a product once I divide 10x divided by 10. So 10 divided by 10 is 1. What I'm left over with is x. I have a plus sign. 30 divided by 10 is 3. If I was to go distribute this back, I should come up with the same answer. That's going to be 10x plus 30. So I haven't changed anything. All I have done is factored out, and I'm writing this more as the distributive property. This is called factoring right here. This is my answer. Number 2, I'm going to find the GCF. I have to find the GCF of 2 and 6, x cubed and x. Greatest common factor between 2 and 6 is going to be 2. And then I have to find the greatest common factor between x and x cubed, and that is going to be x. So I divide by 2x and 2x. I put my greatest common factor outside the parentheses. So 2x cubed divided by 2x. So 2 divided by 2 is going to give me 1. If the bases are the same, I'm going to keep my base, and I'm going to subtract the exponents. So x cubed divided by x to the first, so 3 minus 1 is going to give me x squared. There is a negative sign in there. 6 divided by 2 is 3. X divided by x, they're an identity. They're the same thing. They should go away, but if you're not sure, there's a 1 here and a 1 here. 1 minus 1 is 0. Anything to the 0 power is a 1. And so this right here is my answer. If I was to distribute this back, I would end up with 2x cubed minus 6x. This is not my answer. This is where I started. This is my answer. On letter C, I have to find the GCF between 14 and 56. Greatest common factor between 14 and 56 should be 14. So my GCF is going to be 14. I have to find the GCF between x squared and x, and that's going to, so GCF is going to be x, and GCF between y squared and y, and that's going to be y, because we take the smallest number. So our GCF is equal to 14x to the y. Step 2, we're going to divide by the greatest common factor, 14xy divided by 14xy. We'll write the greatest common factor on the outside. So 14 divided by 14 is 1. X squared divided by x. If the bases are the same, we keep the base, and I subtract my exponents. 2 minus 1 is 1. Y squared minus y is going to be y. There is a plus sign here. 56 divided by 14 is going to be 4. X divided by x is 1. Y divided by 1 is 1. And so I am done with that. Letter D, 3a to the 4th plus 12a squared minus 27. We're looking to see what does 3, 12, and 27 have in common. What's the greatest number that goes into 3, 12, and 27? 3 is the biggest number that they all have in common. So hopefully you're able to see that. And then you're looking to see there's a to the 4th, a squared, and then down here I don't have an a, so that is why the greatest common factor, I will not have a variable. So I'm going to divide all of these by 3, because my GCF is 3. I write my GCF on the outside. Divide by 3. So 3a to the 4th divided by 3. I'm going to be left with my variable. 12a squared divided by 3 is going to be a positive 4. Bring down my variable, minus 9. And then I'm done. You try letter G and see if you come up with what I come up with. All right. coefficients in front of these x's. So I'm just looking at the positive part of it, and I'll take care of the negatives when I divide. So greatest common factor between 1, 4, 23, and 1. And so if you have a 1 here, there's really nothing that you can do. You can't take it any further than that. So the greatest common factor between all of these is going to be 1. Hopefully you can see that they all have an x in common, and when we're dealing with variables, our greatest common factor is going to be the smallest, and so this right here is going to be our smallest. So we're going to have to divide all of these by x. So x right here, that is my GCF. So x to the 5th divided by x is going to be x to the 4th minus 4 x to the 3rd plus 23x squared. And this right here is probably going to be the most missed question, because negative x divided by x is negative 1. So I have to put a number there. If I don't put something there, then that's a 0. So make sure that you write that negative 1 right there. So don't forget to write the constant. So on 1 through 5, you're just writing the GCF. So between 16 and 56. So over here, you'll just go in and write 16 and 56. So you're looking for two numbers you multiply together, so maybe 2 times 8. And so this would be 2. Factors of 8 would be 4 times 2. So that would be 2 times 2 times 2, 56. You can have 7 times 8, and so 7. And then break down the 8, which is 2 times 2 times 2. And then you should be able to see that there's 3 2's. So 2 times 2 times 2 is going to be 8. So that's what you do for the first part. You're just writing the greatest common factor. On number 6, it says factor out the greatest common factor and write as a product. So now you're looking to see, what do 6, 9, and 27 have in common? Well, they all have a 3. So we're going to divide out a 3, and you look at your variables, x squared, x, and there's not a variable here, so you're not going to divide by a variable. So we always write our GCF. So that's my GCF. 6x squared plus 3, or 6x squared divided by 3, so 6 divided by 3 is 2. I don't have a variable, so I bring down my x squared. Plus 9x divided by 3, 9 divided by 3 is 3. Attach your x. There's a plus sign. 27 divided by 3 is 9. Do not forget to put the signs in between, because if you write this, that will be wrong. So that's what you're going to do on 9 and the rest of the problems. Look at question number 9, question on the back. Correlation coefficient. The table below shows the number of stores owned by a popular coffee house over an 8-year period. Using a graphing calculator to find the equation for the best fit that models the data where x represents the number of years since 2009. We never put 2009 and stuff like that in the calculator. So if you're looking for the years since 2009, if this is 2009 and you're looking since 2009, you're going to take 2009 and subtract 2009. So this is actually year 0. 2010 minus 2009, this is going to be year 1. This will be year 2. This will be year 3, year 4. This would be year 5, year 6, and year 7. So these are the years that you actually put into your calculator, not 2009, 10, 11, 12. If you put these numbers in the calculator, you will get a wrong answer. You never ever put those big numbers into your calculator. So you have to go to lists and spreadsheets for this one. And you have to run a linear regression.